Okay, we were taking a quick integral from the UNSW integration, be 2019, number 2. We have the integral from -1 to 1, arc sine of x plus arc cosine of x dx. Okay, the reason I say this one is quick is just because we have an identity for arc sine plus arc cosine. This right here, this is actually just a constant value of pi over 2. And so knowing this, we could just go ahead and integrate pi over 2 and finish it off really quick. But what I want to do is let's just kind of look at how this works. What we can do is put a label on each of these. If I call arc sine of x, we'll call this one t, let's say. And for arc cosine, let's call this y. And so then if t is just arc sine of x, then we can say that sine of t equals x. And doing the same thing for our y value, if y is arc cosine of x, then taking cosine on both sides, we have cosine of y is just equal to x. So then what I can do is just draw the right triangle for this. And here we have two angles in this. We've got t and y. So if we just do it, we'll call this one here t. Sine of t, we can write this as x over 1. Opposite over hypotenuse, so this is going to be x over 1 here. So then our third side on this using Pythagorean theorem, this is just going to be 1 minus x squared. But then I can do basically the same thing on the same triangle. If I call this angle here this y value, then just notice cosine of y, we can write this as x over 1. If you do adjacent over hypotenuse, you get this x over 1. So this actually works. So this triangle here is going to be true for cosine of y and sine of t. The third side on this, of course, right triangle, so this is 90 degrees. Now the sum of the angles in a triangle is just going to be 180 degrees or pi, so I can make a little equation and write this as t plus y plus 90 degrees, and radians is pi over 2, and this is going to be equal to 100, and this is going to be equal to 180 degrees, or in radians that's pi. Subtract pi over 2 on both sides of this, we end up with t plus y equals pi over 2. This cancels out. But t is just arc sine of x, and the y value is just arc cosine of x, and this is going to be equal to pi over 2, and this is the thing that we have here originally. So now that we have this, let's just go ahead and integrate pi over 2, but pi over 2 is going to be a constant value, so let's just bring that out front of the integral, and then we're just integrating 1. But 1's actually an even function, so what I could do is, and the bounds are symmetric around 0 from -1 to 1, so what we could do is change this lower bound to 0, multiply by 2 out front. 2's are going to cancel here. Integrating 1, we just get x evaluated from 0 to 1. Plug that in, and for my final solution of this, we just get pi. Okay, there you go. Quick and easy one from UNSW 2019. Thanks everyone for watching. Have a good day.